In this short lesson, we will be looking at equations and how to calculate the quantities of products formed using dimensional analysis. So here is a reaction for you. The reaction represents a balanced equation for the reaction between propane and oxygen, giving you carbon dioxide and water. If you look at the coefficients, they are 1, 5, 3, and 4. So predicting the quantities of products formed based on the quantities of the reactants we have will not be straightforward. We'll have to do a simple calculation, which will be easy. If you can think it out in your head, well and good. So this is what we normally do. Let's say we have 2.35 moles of propane. How many moles of carbon dioxide will you get? In this case, the relationship is pretty simple and straightforward. For every mole of propane, we will get 3 moles of carbon dioxide. So we will take the quantity that we have, moles of propane, and multiply it by a conversion factor, which is obtained from this balanced equation. That is 1 and 3, the coefficients of the reactants and the products. So we're going to write the conversion factor such that the units of the reactant or the quantity of the reactant that we are starting with gets cancelled out so that we get the final product, carbon dioxide and the moles of carbon dioxide in this case. So we have 2.35 moles of propane multiplied by a conversion factor where the ratio has to be 3 to 1. 3 moles of carbon dioxide will be produced by 1 mole of propane. Now, the units of propane should get cancelled out. Only then our fraction would be right. Here, the units do get cancelled. So the final result will be we have 7.05 moles of carbon dioxide. This is a simple and straightforward conversion. Let's look at one more conversion. Here, the same equation, but we are going to take different reactants and products. So if you have 3.9 moles of oxygen, how many moles of water will you get? The coefficients are different. One is an odd number, the other is an even number. It's 5 and 4. So we want to use the simple method that we had seen in the previous slide to be adopted. So we're going to write the quantity that we have, that is moles of oxygen, multiplied by a conversion unit or a conversion factor. We get the final unit, moles of water. So we have 3.9 moles of oxygen. We're going to multiply it by a conversion unit such that the units of oxygen get cancelled out with the conversion unit. So in the denominator, we're going to have 5 moles of oxygen because 5 is the coefficient of oxygen in the balanced equation. And in the numerator, we have water. It's 4 moles of water. That's a coefficient of water in the product side. Cancel the moles for the reactants and the conversion unit. We get 3.12 moles of water. Something you may want to take care of here is use parentheses while solving equations with different coefficients or different numbers. If not, you can get an incorrect answer. Or use BEDMAS for the calculation. Let's look at one more situation. Here we have a reaction in which glucose reacts in the presence of concentrated sulfuric acid. It's a dehydration reaction, produces carbon and water. I have just written the skeleton equation. I have not included sulfuric acid as part of the reaction. Now, we know that 1 mole of glucose produces 6 moles of carbon and 6 moles of water. So it's simple and straightforward. So if you have 1.44 moles of glucose, how many moles of carbon will you get? Moles of glucose is given to you, multiplied by a conversion unit, you should get moles of carbon. 1.44 moles of glucose. You're going to multiply it by a conversion factor here, which is obtained from the balanced equation. The ratio of glucose to carbon is 1 to 6. We will write the conversion unit such that the unit of the reactant quantity, moles of glucose, will cancel out with the conversion factor, conversion unit. That is moles of glucose coming in the denominator and moles of carbon in the numerator. Cancel out the terms. What remains would be moles of carbon. In this case, we will get 8.64 moles of carbon. So this conversion of quantities based on the reactants and products in a balanced equation will be part of a problem as we go along. So this part should be clear. Now, once you have the moles, you can also convert it into grams. Or if you're given grams, you can convert it into moles and then make this conversion back to moles and grams for the products. So those are some of the operations that you will have to perform while doing multi-step calculations involving limiting reactant, excess reactants, etc. That's it for now.